When we play with Legos, we can build anything. The Lego blocks are perfect modules for building stuff. Functions and software are similar to these Lego blocks. When we piece them together in certain ways, we can create something new. But how can we do it? How do we get started in writing modular code? My name is Heidi Seibold, and I'm a trainer and consultant for open and reproducible data science. I help researchers make their work more open and more reproducible in order to improve the trustworthiness of science.
Hi, my name is Russ Daniel. I'm an emerging technology leader within IBM Research. Today I'd like to talk to you about fully homomorphic encryption.
I am Arturo González Izquierdo. I am a researcher in electronic health data at the UCL Institute of Health Informatics. In this video, I am going to illustrate with an example the main stages in the development and implementation of a phenotyping algorithm.
My name is Piers Keane, and I'm a consultant ophthalmologist at Moorfields Eye Hospital in London, and I'm also a professor of artificial medical intelligence at the Institute of Ophthalmology at University College London.
Imagine you're a scientist in the early 1950s.
Hello.
You've noticed that lung cancer rates have increased dramatically in the last few decades.
In the year 1912, there were only 276 known cases of lung cancer in the whole United States. Today, it kills more than 35,000 Americans every year.
And you suspect that tobacco smoking is the cause.
Now, these statistics show the interesting parallel between the increase in tobacco consumption and the increase in lung cancer.
So you decide to test your hypothesis with an RCT. You recruit a group of healthy adults aged 18 to 28, let's say, who never smoked, and you randomly assign them to two groups. One of these groups, the treatment group, is given a packet of cigarettes to smoke every day.
You smoke a pack of cigarettes a day for a year, and a full quart of these poisons will be poured into your bodies.
While the other group is given a packet of fake cigarettes. And you're going to have to keep this going for about 50 years, keeping track of how many people in each group get lung cancer. If there's a measurable difference, then your suspicion was correct. Any problems? Well, unsurprisingly, this study never took place in humans. It's completely unethical to prescribe a potentially harmful substance that has no known or suspected health benefits, even if it's for science. It's also completely impractical to run this study. In our hypothetical trial, the participants probably aren't going to take up smoking just because we're giving them cigarettes. In fact, we'd probably have trouble getting people to take part.
I'm quitting. You can take these cigarettes and use them to kill mice or something. I'm finished.
One of the most common strategic decisions for digital health companies is which market to enter first with their medical device. The United Kingdom, the European Union, or the United States.
If you want to have a system where we learn quickly, where we have research and science informing guidelines and making care better in a reasonable timescale, learning health systems are the best way to do it, but they require IT and data infrastructure and training to be in place to do that.
Socio-technical factors refer to both the technical and the social, human and organizational factors that can affect health information systems in either a positive or negative way.
In this video, I will share with you what the lack of reproducibility has to do with research waste and how simple reproducible research practices can help you in becoming a better researcher.
And we're going to explain p-values using a little bit of storytelling. So imagine you're involved in a role-playing game with some friends. You're in a dungeon fighting a dragon, and one of your friends is the game master, or GM. That means she's in control of the dragon and its minions. Whenever she attacks someone in the game, she secretly rolls a 20-sided dice, or D20, behind a screen to see if the attack is successful. And if she rolls a 20, then the attack is a critical hit, or crit, which deals double damage. Now, you've started to get a little bit suspicious of the GM because she's been critting a bit more than you might have expected. However, you don't want to accuse her of cheating without some solid evidence. So, what do? You decide to wait until the moment is right. you keep track of her next 200 D20 rolls, and you note that 15 of these are critical hits. Now, on average, you'd expect 1 in every 20 rolls to be a crit, so in 200 rolls, you'd expect 10 of them. 15 is certainly more than this, but is it significantly more? Is it big enough to justify her accusation of cheating? Well, you have an idea. You can calculate the probability of seeing 15 crits in 200 rolls on a fair D20. This is given by the binomial distribution, which looks like this. All you have to do is plug in the numbers, get a probability, and decide if this is small enough to accuse your friend of cheating. You decide that if the probability is less than 5%, then you'll say something. So you do the calculation. The probability of 15 crits in 200 rolls on a D20 is about 0.034, or 3.4%. Well, this is less than 5%, so you go to the game master armed with this airtight mathematical evidence. And now she's furious at you. She comes back at you with a counter-argument. Looking at the binomial distribution, your friend points out that you could make all of the probabilities as small as you want, just by increasing the number of rolls you record. She says that you could accuse anyone of cheating using this method. All you've got to do is keep recording their rolls until you reach an outcome that's below your arbitrary 5% threshold. The problem is, as the number of rolls increases, so does the number of possible outcomes. That means the probability of each outcome has to decrease.
In today's world, data is king. Researchers collect large amounts of information from various sources, such as electronic health records, clinical trials, and surveys. However, with such a sea of data, researchers can face many challenges with inconsistent data formats and mismatching fields. The number of ways we can go wrong is almost as vast as the data itself. Imagine walking into a supermarket and the fruit aisle displays bunches of bananas measured in ounces at one counter and pennyweights at the other. In fact, the UK only enforced the use of metric units for loose goods in the year 2000. In this video, we'll explore how data standardization is used to define and implement rules for collecting and formatting health data so that it can be used efficiently for research.
And then if we were to go to our CSS document, we can then refer to it in the following way. So when you create your own styles using the ID, you need to precede the name with a hash. So you use the hash symbol and then you write the name, your custom name for your element, and then you can provide additional styles as you see fit. So in this case, we're going to make the text color dark green as opposed to the dark blue color of the other paragraphs. And when we run that, you can see what it looks like here. So the standard paragraph here is in a dark blue still, but our sub paragraph is now in dark green.